Thank you so much. Again, I am Ana Carcedo. I'm the Broadleaf Agronomist at NDSU. And as Jeff mentioned, I'm quite new. So if this is a new phase, it's something that you should be expecting that, okay, this is new. So I will be talking today about variety trials and how to use them. And this is actually a topic I choose for all the Getting It Right webinars that we have been leading. It's just important information. Probably you notice, because if you're a farmer or if you're an agronomist, you have been doing this every year. So you have been selecting your varieties, you have been doing a lot of the things that I'm going to be mentioning. So saying that, what we're going to do today is just doing a recap. We are going to be mentioning some concepts and just trying to refresh them. So saying that, I'm just going to start with a little bit about which is the importance of drive-ins in North Dakota. And saying that, I have to say that, okay, North Dakota ranks #1 in production and acreage in United States. So we can say with a little bit of confidence that, okay, it's an important crop, but also something that we should take into account is this. This is how the production, yield, and acreage planted changed across time. And what we can see here is that it's been really, really variable in the last few years. And saying that, when we're talking about this information, this is provided by the USDA NAS, the surveys of United States. When we see this, we are just seeing one line, but this is not how we should consider it. When we are talking about drive-ins, we have to say that it's not just one crop. It's a lot of market classes, and they are so diverse. Like, people, when they're seeing this and they're not related to ag, they might even think that they're different plants. It's great, the variability that they have. And then again, when we're talking about North Dakota, we are talking about market classes, what we are seeing here is that most of the market class percentage is occupied by pinto beans. Half of the dry beans that they are being grown in North Dakota are pinto beans. This is information from the dry bean grower survey that was done on 2022, so there might be a slight difference, but pintos and blacks dry beans are the ones that they're leading here. Saying that, I just wanted to give that brief introduction. I'm going to be mentioning some concepts. If you have been connecting to previous Getting It Right, you might find that this is information that I already provide. But again, this is so important to make decisions. So we are going to talk a little bit about how interpreting agronomical data. Saying that, how can we ensure that the data that we have is reliable? And here I'm going to mention 3 things that they are really related to using information provided by a university. First of all, a university is completely unbiased. It's not trying to sell any product. It's just trying to provide information. So that's a key point when we're talking about information provided by a university. Then, especially in NDSU, we have to be so grateful that we have the research and extension centers across all the states. And that's something that we should be grateful. It's not something that happens in all the states. So we have a strong network across the whole state. And then I'm highlighting their experimental design, and basically it's not the experimental design itself, is the people behind making the decisions. So we have specialists, we have agronomists that they really know what they're doing, so that ensures the quality of the data. Saying that, experimental design is a concept that's more from statistics, but in agronomy we have to use it a lot. And there's 2 things when we're considering experimental design that's really important. The first one is having replications, and that's something that you might have heard before. So in this just diagram that I just put there, we have different colors that will be different varieties. In the case of this presentation, it could be different treatments. What we are seeing there is that each one of these balls are repeated at least 4 times. And that's something that we do in all the variety trials that we show the information. You might see only one number, that's an average, but that was done at least 4 times. When we're talking about replications, it's actually really important to talk about which variable you are measuring. So when we're talking about yield, we say 4, sometimes 3. But if you're measuring something that's really, really hard to measure, then we should say, okay, we should have more. For example, when we're talking about things that they are measuring the soil, we usually, like microbial activity or something like that, then we should take more into consideration more replicates. Why I'm saying this? Because I want you to ask these questions. When someone is coming to you, actually telling you some results or something, it's something that you can ask. You should ask. You should talk about, okay, tell me how many times this was replicated, in how many sites, in how many years. So all these questions are so important to know how robust the data that they are sharing to you is. So saying that, of course, in the university, we try to do everything right, but just for you to consider if someone comes to you with some results, you should ask these questions. So the second concept that's really important when we're talking about experimental design is if these repetitions were randomized. So basically, when we're talking about a field, and you can even think in your own field when I am saying this, we know that it's not homogeneous. It's not all even. We know that there is a lot of variability in our fields. And saying that, the way that statisticians found out that they can deal with this variability is just putting on repetitions in a random way. Saying that each repetition has the same probability of being placed in one section of the field, and that helps to deal with the variability. So there is 2 kinds of variability in an experiment. We have the variability that we want to measure, that's the one of the varieties, in this case, and we have the variety that's the one that we don't want to measure. It's the one of the field, the one of the weather, the one of the topography of your field that we want to ignore. We want to highlight the difference of the treatments that we want to measure. Saying that, randomization is the way that you should go. Then the next time someone shows you information, please ask how many times this was repeated, how many years was this repeated, in how many sites it was this done close to my field. Is this really representative of my conditions? And then also ask if this was randomized. There is a lot of times that you are going to go to field days or demonstrate, and you're going to see demonstrations. And the key point of this demonstration is that they look nice, and I'm saying it's a good educational tool, but it's clearly not scientific. So usually you will see all the treatments organized in a gradient and things like that, and that's not representative. So just consider that when you are seeing these things. Saying that, I'm going to be using this example from soybeans, but it actually works for any crop. It's the idea of that solely comparing average difference can be misleading. And we are going to see that in this example here. So here we have 2 varieties, one is X and the other is Z. What we can see here is that you can see kind of a trend that variety Z is a little bit higher in yield. You can see a trend. But when we see the p-value here, that's the probability that they are actually different, we are seeing that it's 52. That 52 means that there is only a 48% of probability that they are actually different. So it's almost like throwing a coin, 50-50. Maybe they're different, maybe they are not. When we are talking about p-value, we want that it should be significant, at least at 0.10 or at 0.05. So it's like saying that you have only 10% chances that they are not different. So saying that, we see this, we see a trend, but the statistics says, okay, this seems different, but it's not. And we're going to see why, what is behind this data. So we are like, let's check the raw data here. So again, we have our repetitions, and we check our first repetition, and we say that it's 53 against 52. So it's they're pretty much the same. They're really close. We go to the second repetition. And the variety Z is actually even a little bit higher. So there is no really consistency here, right? And then we go to the repetition number 3. And here we see a huge difference. We see that, and it's actually even suspicious. There is something here that might be wrong. And we go to the 4th repetition, and again, they're pretty much similar. So when we are seeing here, what we are seeing here is that basically the most part of the difference that we are seeing in the average is led only by 1 repetition. This, if there is an agronomist checking this data, they might consider that the repetition 3, it's an outlier, and this difference probably is due to maybe a measurement mistake, or maybe there is a clear problem or difference in that part of the field. So there is a lot of way to handle this data. But in the end, if we see only at the average and we see the p-value, we can see that they are not different. Then, like the take-home message of this whole slide is, a small but significant difference, it's more meaningful than a huge difference, but that is not significant. So take that into account. Saying that, there's another concept that you might have seen a lot of times and that you might have seen a lot of times in the variety trials or in any experimental data that you're seeing, and it's the coefficient of variation. And when we're talking about coefficient of variation, it has a nice definition that it says individual observations are close to the experiment average. So I love this definition, but for me, it's kind of hard to understand. I'm a really visual person. I understand things with diagrams and things, and that's why I prepared this for you. So if you have a low coefficient of variation, you will be in the first target. So all your shots are close to the center, to the bullseye. So if you have a high coefficient variations, you can see that you are all over the place. That's a good way to represent it. And then if we want to see that in like with actual data, here we have an average of all our observations that is, I think it was 33. And then we see that all the observations that we have from all the repetitions that we have from 1 to 4 are really close to that average. So it doesn't vary much. So that's a low coefficient of variation situation. But if we want to go to high coefficient of variation situation, we have exactly the same average, 33. But we can see that all our repetitions are all over the place. So this gives you a lot of information about the consistency of your data and how reliable the information of the repetitions is. Saying that, these are the concepts that you are always going to see in our variety trial booklets, and that's why I wanted to mention to you. So we are going to be talking a little bit now about our variety trial booklets. Let's go into it. So again, something that you might be tempted to do is just averaging all the information that we give to you guys. In this case, I just average the information across sites, sort them from the higher to the lower, and just based on that. And as we saw just now, the average, it's just not good enough information. And here we have an example. So we have this variety trial that's from our guide, and it's from oaks. We have all pinto beans and the slow darkening pinto beans as well. So this information it's really valuable. How should we interpret it? So we have the LSD here. That's the least significant difference. So which is the minimum difference that two values should have to have a difference, a significant difference with a p-value of, in this case, I'm pointing out the 0.10. So what we are going to do now is we are going to focus on this column here from 2024. That's the latest information that we have. We are going to see that, okay, and the rodeo in this site was the one with the highest yield that presented that. And our LSD value in this case is 200 for 0.10. In this case is 215. So basically, the only one that presented non-significant difference with ND rodeo in this case was ND palomino. The others had significant lower yield compared to in these conditions. So if you're choosing only based on yield, these are the two that rank it the highest, and they are basically the same. Even though you have that almost 200 pounds difference, these are not statistically different. But compared to the others, yes, it is. Saying that, there is a lot of information here. There is a lot of sites, and that's there is a lot of things that we can do with all this valuable information. So something that we like to do as agronomists is trying to make trends. And when we do that, I'm going to spend just a few minutes explaining what this figure that I'm going to show you it is. So in the x-axis, we're going to have the mean yield across sites. So each one of the points that you're going to see in the x-axis represents the average of one site. Saying that, it's really representative about the environmental quality of that site. And then in the y-axis, we are going to have the yield of each variety. Saying that, and we have a lot of varieties because and these are all pinto beans. Saying that, there is a lot of information here. Let's see it. And yes, if you see this, you are going to say, okay, this looks just like a spaghetti. All the lines are crossing, and this is called actually interaction. So what you can see here basically is that there is not one variety that does like this, that is the highest in all the environments. So in all the sites that you are going to see, the one that behaves the better, it's going to actually be different. That's just to prove that point. Saying that, I'm going to show like a more simple representation of the same figure. We can see here, I included the labels of the different sites. So the average of Hettinger, in this case, it was close to 1,000. The average yield of Hatton and Staples is close to 2,000. It's the same figure as before with the mean of the sites in the x-axis, but in this case, I'm putting the labels just because in the other it was too crowded to include them. So saying that, I just selected 3 varieties that we can see in 3 different colors here, just to keep it a little bit more simple, and we don't see that many lines crossing each other. Basically, what we can see here is that, for example, Monterey behaved better in the sites with higher environmental quality. We can see that ND rodeo had better behavior in the ones in the middle. And then again, like USDA Rattler behave better in the ones with the lower yield quality. Saying that, this is why we say always it's so important that when you're checking the data, check data from sites that are close to your farm. That's really important because there is a lot of interactions. There is a lot of things changing and how each variety behaves in different sites that this is just to highlight, please check the information that's close to your site. And saying that, there is also another point that it's really relevant and NDSU provides this information, is that it's not only your site, but it's every year. We know that the weather is different every year, right? And it's really challenging, and it's really different how each site behaves with different weather. So what we can see here is an example from Langdon. We even in the variety trial booklets, you can see it. We have data from 2021 to 2024. So we will have 4 years of data, and all these varieties were repeated in all these years. And what we can see here is that even though we have some varieties that are always down, that probably we shouldn't choose. We have some varieties that here they behave better in most of the years. That even though it was a bad year like 2021 or a good year like 2022, they're always on top on terms of yield. So we have Vibrant and Thorium that behave better in terms of yield. So check your site, and then the second thing, check if you have more than 1 year of data to check that information. Saying that, there is also a lot of other traits that we know that we should consider. So in these variety trial booklets, we usually provide information about days to flowering. And what I did here is just a summary of all the varieties that we have that we provided days to flowering and the yield. So in the y-axis, we have yield, x-axis, we have days to flowering. And what we can see here is that in terms of day to flowering, we have a variation from 40 to 55 days to days to flowering, and we cannot see any trend. So in this case, we cannot see that longer or shorter days to flowering actually change your yield. We have here it's just variability. There's no trend here at all. Then when we go to days to maturity, it might seem that we have kind of a trend saying that the longer days to maturity, you will have lower yield, but that's not true actually. If you see in each site individually, and that's why I put different shapes for different sites, in each site individually, there is no trend at all. If we focus on the circles here, it's just variability. If we focus on the triangles here, there is no clear trend within sites. So this is when checking data might be a little bit tricky. So for this year data, for pinto beans, for all these varieties, we did not see any trend for days to anthesis or days to maturity regarding yield. Saying that, this is kind of a summary. So when you are choosing your variety, use data that summarize several years and several locations. Choose a high quality cultivar that on average perform the best in multiple locations near your farm. That's during several years. This is, again, what we want to highlight and how we recommend to use your variety. And there is one thing that we should not forget, and is disease behavior. That's ugly stuff, right? So saying that, NDSU provides a scoring for root rot, to white mold, to common bacteria blight, and knowing your field, knowing if these are things that you should take into account, it's information that's provided, and you should check it. Sometimes you should try to aim for the highest yield, but if you have any of these problems, it's things that you have to consider. Saying that, we were mentioning before, we are always talking about pintos in this presentation so far, and there is something that's really interesting, and it's really particular of pinto beans. That's the slow darkening pinto beans. So it's might be really challenging if you have delays in your. Okay, I will go faster. It might be really challenging if you have any delay in the harvest, and how this actually affects the quality and the price of your product. So saying that, slow darkening pintos have a lot of advantages besides that they get darkly slower. They cook faster and reduce fuel requirements. So that might be something that might be requested by the industry in the future. It's something that it's an advantage of pinto beans, of a slow darkening pinto beans. Nobody wants to actually spend more money. So and having something that reduces the fuel requirement, it's going to be really advantageous. So the seed quality and the yield, as we saw previously, it's really competitive, and they're all upright plants, so it's really easier for mechanical harvesting. And something that's really interesting that they just find out is that they're actually more nutritious. They have higher bioavailable iron. So key things to consider when you're choosing which pinto beans you are going to plant this year. Saying that, I don't want to finish my presentation before mentioning the new NDSU variety and the Galaxy. And I want to highlight all the efforts of NDSU breeding program. So it's not easy to release a variety. It's a lot of work until you find the right line that you want to promote. And then once you find it, it's not, okay, just release it. They actually tested from 2017 to 2024 across 24 environments. So this has been tested long and extended. In terms of yields, it's really close to Eclipse and Blacktails. Also, comparing with the previous NDSU black beans variety, that's ND Twilight, it has no longer that purpling problem. And then when we're talking about canning quality, it will be similar to Eclipse. Saying that, again, we have upright plants, which it favors for direct harvest. And something that's really, really different to comparing to any of the other black beans varieties that are available in the market is that it has way better behavior when we're talking about common bacterial blight. So these are the key differences and similarities of this variety compared to the others in the market. And I think we are going to put in the link of this variety in the chat box. So check for that if you want to see more details on actual data. Saying that, I'm going to invite you as well if you're around. We are organizing a Western Crop and Pest Management School on March 5th and 6th. I hope to see you there. Check for more information in the chat box. And then say that, thank you so much. I don't want to go over time. I think I nailed it this time. I always like to share this. It's a share box. So if you have your phone close by, just scan it. And there is a lot of useful resources regarding dry beans. I put more management information in this share folder this time, more about plant population and things I didn't discuss today.